to start with islands architecture, right? We have to take a step back before I say this is islands architecture, this is how it's gonna change. Before, let's start little simpler. So first thing is how to use JavaScript. So this is the first step we have to learn before we actually go into like how the islands architecture is actually going to help us for especially a new developers like you are just now starting off with front end, why you should need islands. Before that, let's see how people are using JavaScript right now, how it is being used. Okay, to start on that, what I did is I built a simple application. Okay, the agenda is very simple. First we'll start with React and the modern ecosystem, how I built like a very simple React application. Okay, second point is what was the problem with that React application. Obviously I couldn't actually build a huge application which actually showcases the performance problem and everything, but to my extent I started off with a very tiny project to show you guys what was the problem and how we are actually planning to address it step by step. So it's just 3 pointers. First, we will learn the React ecosystem, how to build a small application. Second, we'll see the problem that I am like focusing on. Third, we'll see how to solve that problem. Okay. So React basically started off by introducing two important things to the Angular generation. Because before React, we were all doing Angular. I genuinely hated Angular that time. I was doing jQuery. So we used to be team jQuery when React came out. So I was like building college websites and stuff. So first thing what React introduced is it introduced a concept called UI reactivity. So previously when we had to like perform any kind of operation on the UI, we used to like tell the DOM through JavaScript saying, add this class, attach a children element, change the text content. We used to like imperatively keep on telling that DOM, this is how you have to like change the elements and stuff. But React basically what they came ahead and said, you just set a state, you connect that state to a DOM, you change the state, all of a sudden your UI is in sync. That reactivity basically like was the biggest change React came in. So second important thing it introduced is it introduced component driven development. So basically what component driven development did was that you build one header only once. Then you just import it anywhere in your page where you needed a header to be displayed. That's like the very simple crux of it. So whenever you need like a piece of user interface that you needed to use, you just build it once, let your components share everywhere. So this basically introduced the whole new concept of like design systems, UI toolkits. Like your brand itself had its own theme. You build a design system on top of the brand theme, saying that okay, now if I change the color of this button, everywhere in the website it will change. And then we get to be very scared of changing the color of the button because it changes everywhere in the page. We don't know the effect of that. That's a different problem, like how we manage UI components and design system. But React was the one who basically pitched the idea, which right now is followed by all the other frameworks like Svelte, Vue. You pick any modern framework, they will have these two mandatory. There is like no framework that in today's state builds without reactivity and builds without the component driven system. But when React made the UI react to states, right, a new paradigm shift happened. So what happened is previously we were like building multiple page apps using Django, Ruby on Rails. So basically like every route we render like a HTML page, and in that HTML page we add some bit of JavaScript here and there to say like when you do form validation, this is how it should work, etc., etc. But React basically like championed the era of new single page application development. So there were like tools that came about on top of React. So the first thing that became extremely famous was this thing, React Router. So even this is not something built by the Facebook team. This is not how Facebook team envisioned React when they released it. Even the very first tutorials of React had like adding React as a script tag and working on that. But when React Router came, it actually let you build the entire web page end to end from the beginning, from the header, footer, everything became like a single React component. And all the navigation is taken care of by the React itself. So you click, it's a single page app transition. Instead of like loading an entire new HTML page, it downloaded a small chunk of JavaScript and just swapped the screen based on the new URL. And Then we got like Next.js, which basically like built, improved on that concept by rendering the first HTML on the server side. So now what happens? You go to a page, first HTML will be served by Next.js, then React will take over. And once React takes over, you have full interactivity, the SPA experience is preserved. But your app for search engines or places where there is no JavaScript environment behaves like a multi-page app. So this concept was called server-side rendering. Then we got Gatsby. So what Gatsby did was it basically went even a step further. You generate all the hundreds and thousands of files at build time itself. You get static site generation. So for blogs, for pages that are like extremely content heavy, people started like building React pages that applies to a specific format and extended it out. So there were like thousands of pages generated at build time, and when actually server goes and starts requesting, it only like loads that HTML first, but not exactly HTML. They were still all like rendering React on the client side, so that the same SPA experience is like preserved as the user is like moving across the screen. Then we got like React Query, which is like a complete server state management. Then we have Blitz, which basically like applied all the concepts on top of Next.js. Soon the ecosystem started taking off. But this is where things get like interesting. So as and when we are like getting more interactivity, we are like getting more SPA experience, the web apps over time all got it started getting slow. This should be true for anybody who is working with React. After a while, your application will be like slow, because it has been like a problem plaguing me for the past 7 8 years. Pretty much all the application when I start, it will be like re- pardon, coming to that reason. So it's usually not the problem on the developer who is like writing bad React code. There is a much more sinister reason behind why the web is getting slow. But why is it getting slow? Because we do lots of optimizations. Like people write lots of memo everywhere, thinking less re-renders, it will like somehow make the web faster. But the thing is, memo actually makes it slower. What people doesn't know is that it increases the memory complexity of the app. There came like lot of things, like people started like tree shaking like crazy, like write webpack builds, let's do tree shaking, let's do dynamic import, let's do lazy loading. Even tools started like introducing lots of like workarounds how to keep your application faster. But let's take a step back out of all of that current trends, and let's see why your application is actually destined to be slow, regardless of whatever things you put in place. So I built like a small application, like very simple application. Probably like kids coming out of college, like new freshers, they can like write this app in like few lines of code, probably 10 15 lines of code. Okay, let me just open up the app, and let me also like zoom in a bit. So this is the app. So this application is like has a calculator as a location generator, and two pages like home, about, calculator, stuff like that. Calculator is just a calculator where you add your equation, it just returns the result. Okay, it can go for, let me just write a simple calculation here. Okay, let me just write like a simple calculation to confirm this is the calculator app, it's working as expected. Okay, then I got the location app, it asks for my location. Oops, preferences, I need to like turn on the location preferences. Let me try again. Okay, yeah, got the location. So that's it, it's a pretty simple app, straightforward as you can see. Let me also share the code of the application. So it's a Next.js app, so it's built with Next.js. So here's the package.json file. So this application is built with three, four things. It uses Next.js. Uh, Let me also zoom that in a bit. So it uses Next.js, it uses React, it uses React Hot Toast for that small toast that you guys saw. It uses React Strap, which is like Bootstrap, UI components built on React. So pretty standard stuff. Let me build my application. So this is my index page. You can see I got some things. This is the calculator, and I also got a bunch of components, the header, the nav bar. Usually this is how you build like a simple application. Even if it is Next.js, nothing much complex. I just have 4 or 5 components, just rendering those components. Now let me go in and check this application out. Let me go to the home page and let me go to the network tab. Let me also zoom this in. First thing is I need to see when this application loads, what is my computer like loading in. So let me restart it with the empty cache. Now here is the thing. When I loaded this, you will see along with HTML, it downloaded a bunch of JavaScript files. Okay, and those JavaScript files basically have like Webpack, which is like the first JavaScript file that loads and like pulls in the other JavaScript files. Framework, which often contains React, Next, all of these framework related stuff. Then you have the actual main code, which is like shared modules across all the things, and you have the underscore app, infamous in Next.js. It is like the single file that connects all the other pages in Next.js for that SPA transition. Then you get build manifest, and finally the actual code. The funny thing is the last two, the calculator and location, are the actual code that I wrote. They pretty much like loaded the last. And also look at the size it took for these pages to load. It has got like some 40 KB, 29 KB, 30 KB. So I just added it all. That's why I built the calculator app. So it came down to like some 100 KB in size. So let's just say that on average our code has like 50 characters per line. Okay, and that means 1 KB basically has like 20 lines of code. So going by this calculation, the browser basically somehow executed like 2000 lines of JavaScript just to like run this tiny app, which is basically nothing but a eval on top of a string. That's it. It's technically a one-liner, that entire calculator. It just runs eval on top of like a string, but somehow our browser executed like 2000 lines of code just to like display this. This is pretty much the reason why your applications often start getting slow, because the framework that we are building has to account for single page transition, has to account for entire React states that is going across. It has to account for all the things that is actually not needed by you, but to be a general purpose JavaScript framework. And it has to load all of them just to like make your entire application work seamlessly. Now, what happens if none of this JavaScript is actually there? So since this is built with Next.js, it's a SSR framework, server rendered, which means the first load basically provides all the needed HTML that needs to be displayed. So what I'll do next is I'll just turn off my site's JavaScript fully. So I just went ahead and blocked the whole JavaScript of the site. Now I'm reloading it. Now, surprisingly, it didn't show any much difference. It still got the home calculator and everything. I go to the calculator. It still loaded the calculator. Pretty much all the first rendered HTML is still sitting there. But if I click on the calculator and I try typing something, nothing will happen. The actual code logic will not execute. That is because React hasn't taken over this yet. So usually after the HTML renders in Next.js pages, it runs another round of render where React runs and it takes control of every single DOM element, so that interactivity can become part of the actual application. So right now, if you turn off the JavaScript, this is pretty much how Google's crawlers are like seeing this page without any kind of interactivity. So now back to the problem. So we are able to like get an entire page up and running, but somehow before our actual logic runs, we are like loading some 2000 lines of JavaScript. And if I go to my home page, technically, there is no interactivity actually here in my home page. It doesn't need, if anybody lands on my home page, they don't need to load any JavaScript at all. but you are still forcing that page to like load some 100 KB of JavaScript. And these JavaScript, as and when they are loading, they lead to like render block times. So if you look at the Lighthouse, there will be a measure saying that this page has been unresponsive for this much time when it loaded. That is the time React is actually like taking control of every single DOM. So if your page has like thousands of DOM elements all rendered with React, that is the time taken by React. That's React's nature. That is how it's supposed to work. We cannot complain it, saying it has to be much faster. That's an endless loop if we keep on trying to make frameworks more and more faster. So what I did is I thought, okay, let's see. This is how the application was supposed to like function. I just wanted like two small interactivity. One is a simple calculator, one is a simple location, but it's taking too much code. So what is the bare minimum I can go to actually get this app to be as performant as I expected? So what I did next is I built this app again. Okay. I'll come to this review of this app later. So let me go to localhost. And this is basically the Next.js app. This time it is like running in developer mode. Let me also like turn on React Dev Tools. Ouch. I basically had to like uninstall React Dev Tools because it injects an unnecessary amount of JavaScript inside every page load to check if the page is like running React or not. Okay, I got the React Dev Tools. Now this is my local host. Wait, I think I'll have to like close and open the tab again. Okay. So here is where things get interesting. So if you look at this, first thing you will notice in the React component tree, right? The first 10 components will not be the component that you are actually wanting to render. There will be like some things like error boundaries, contexts, some router contexts, like some 10 contexts before your app actually like gets to execute its own code. And in larger applications, it goes crazy. Like every page tends to have so many HOCs on top of them. The header of this app has to like wait till all of this context actually finishes executing. Okay, this is not something that we will be aware of when we start building the app. We start with an Next.js app, we just go with the speed. Because they are there, we build really fast. But we have to like get a lot more efficient here. So this is like obviously a very bad way to start a project that's supposed to like be very performant. So what I did is I built the same page this time with just Bootstrap and HTML. Instead of like going and the moment I saw, okay, there is like this many wrappers around it, I was like, let me go to the basics 101, build the entire thing with HTML. And this is what I got. So surprisingly, it looks exactly the same because I just took the exact same classes just to like show the difference. I just added like built with STM below. So STM is a framework that I used for building things with HTML because turns out I am like so bad at writing plain JavaScript. I had to like go back and figure out some framework that looks like React to work with this. So now let me inspect and show you guys how the network works. Not the performance, the network tab. JS is selected. Empty cache and hot reload. What is that install hook? Yeah, that is React Dev Tools. Let me disable Dev Tools. This is that JavaScript I was talking about. Yep. Now you see you have like a page that looks exactly similar, but this time there is like no JS that is loaded. Okay. Now I go to the calculator. And here you will see this entire calculator totally took close to like 6 KB of JavaScript. Okay, and the framework that I used is STM, and this is what my calculator's logic will look like. So this is like a framework that looks very React like. So this is built by the guy who built micro bundle. So you can, I have added the links and all in the presentation. So this HTM framework looks similar to React, but it can run without any bundler. You just include a script and it builds the component. So if you can see, it just renders the HTML part, and it has this dot set state. It sets the state whenever like input changes. Now going back to the network, the entire page load with the same functionality, I still get the same calculators functionality working. Everything is the same, but 6 KB. Now if I go to my location page, this will also have like another few KB, 845 bits for the location JavaScript, and the previous JavaScript file was already cached. So it just says like took from disk cache. And about page obviously doesn't have any JavaScript. There is like no interactivity here. Cool. So this actually makes the page perform really well. But is this the right way to like build any new application? Because I can go through the code. I can like go through the code for the HTML thing and basically show you this is my index.html. So you can see this is how we used to like write HTML back in the days. We say like header component starts here, it ends there, and with like zero reusability of any components, we just duplicate this across every single screen. Every screen will have that header, footer, all of this. We used to like automate this HTML a bit using like frameworks like Express, Ruby on Rails, and stuff. But there you have it. Like this is the bare bones I can go if I want to like build the application with very minimal JavaScript load. But there is like one interesting thing I'd like to show you between these two apps. That is like straight example of where the whole single page application falls apart. So this is my single page app, which is built with Next.js. I do a refresh. There'll be like a small feedback form that will pop up every 5 seconds. Where is that? That's weird. Yeah. So why is it like not showing up here? Yeah, my bad. Thanks, man. I disabled the JavaScript. Let me turn it back on. Cool. So what you'll see is there will be like a small pop-up that shows up every 5 seconds. Okay, but if I click on it, what will happen is it will crash my entire page. And if I try using it, somehow it just makes my entire page go blank. So early days of React developers know that white screen that shows up whenever your application like throws a small error. And now if you see this message, so this is basically a screen put by Next.js team whenever like your application executes a runtime exception. So what happened here is, since React has taken over the entire DOM, your application from end to end, from header to footer, any runtime exception on that thread basically can destroy your entire application. That feedback can be like a small widget that somebody like coded in a rush that is like sitting in a React DOM tree. Just because that feedback thing threw like a small exception, runtime exception, React's entire DOM tree broke, and the only way to recover from this error is you have to like refresh the whole screen and hope that nobody clicks on that submit when it shows up again, because you click again, the entire application will go dark. And this is a problem that is plaguing React for a pretty long time, because the entire DOM is represented as like a single JavaScript line. At the end, it's just one huge JavaScript file that is like running everything. Now, for this, people introduced error boundaries. You have to like keep on wrapping everything in error boundary, and the error boundary you have to give like a fallback UI, you have to give a reset UI, etc., etc. This is a problem unique to SPS. Any SPA framework, if you made the entire DOM tree like a single JavaScript, it runs into this problem. But here is the thing. The same thing I built with HTML. So let me open the console also to show you guys the error. So this is an error that should be like very familiar to you. It basically says cannot read properties of undefined 0. Okay, the same error. This time, this is my about page. There's also I put a submit button. I click on it, the page doesn't do anything. I kept on clicking on this submit. Nothing happened. I can go around and move across the application. Everything will just continue to work as it is. But when I go back to about again and I check my console, okay, when I click submit, it just shows there is an error. I don't know what to do with it. And the rest of the page is safe because the entire page is built with HTML. That one small component, whatever problem it has been like completely isolated within that page. So that is like one interesting bonus I noticed. Okay, I just took the JavaScript out. I made the page isolated completely. Now one component's exception is not bothering the other components. So problems are also like extremely isolated. But the biggest problem I had is while building the app, I wanted to change like one small footer link. I had to like change that href. I had to like change it in 4 different files because I wrote all of them in plain HTML. And I went in to check what is the status of HTML imports, which is supposed to build reusable HTML. Basically, that it has been discontinued. Safari is not going to implement it. Firefox is also not implementing it. Only Chrome is having that support. So that was painful. Basically, we are like completely lose the component driven development we had just to like build much smaller interactive apps. Now, this is not a problem that is uniquely faced by us. It's faced all over the developer community right now, SPS. Okay, as you are building, as your application starts growing, this kind of runtime exceptions are gonna happen. And you cannot expect to like wrap every single component you are building inside error boundary while building a React app. And you also can't expect the pages to like perform really well, given that you are wrapping your components against lots of providers. Over a period of time, like you write 50 providers, 50 different contexts, it's gonna slow the page down, regardless of whatever tree shaking or effort you do. Now, how did the islands architecture like come into play here? So this is the next generation of front-end frameworks, which are all moving to this islands paradigm. So the idea behind this islands paradigm, I'll come to that. So you render the page as HTML. Okay, you use whatever tools you want, you render the page as HTML. Only in the specific places where you need the interactivity, you attach React to that place. So unlike me, who is like writing everything in HTML, you write everything in a component-driven framework, component-driven environment. I'll show you guys the code also. The next, I built the app 3 times. First, I built it with React. Second, I built it with plain HTML. Now, I built it with islands. So first framework that came out with this is Astro. You guys would have heard about it when they raised like a huge funding. So Astro introduced the concept called Astro Islands, where you write and render HTML, and wherever you want to add interactivity, use whatever language you want. Use React, Svelte, Lit. It doesn't matter. What they promised is it will be interactive all around. Ouch. Let me share the screen again. Okay, screen share is there, right? Oh, cool. So Astro introduced it, and one of the most famous framework to adopt this is Next.js 13. So the term they use is React Server Components. So the idea behind React Server Components is you write a React component, but when it renders, right, it will render only once, that too on the server side. For the client, it just comes out as plain HTML, which means like zero interactivity. And if you want to add interactivity, Next.js 13, what they did is they made you opt in to interactivity. If you want one component to interact, to respond to user events, you have to like write use client on that component. Otherwise, the component will only render on the server side. It will only render HTML. JavaScript won't run at all. Then fresh. So this is built by the Dino team. So this uses Preact. So this is extremely well-made framework. It's basically like made web development a lot easier. I'd highly recommend you guys to like try fresh after you go home. Another one is Easeland by Levante. So Levante is a static site generator like Gatsby, but Levante is like extremely like fun to use. when you're doing like static site generation. And they also came up with EaseLand plugin, which basically is a term for island. So let's look at the app that I built again for the third time, this time with islands. Again, this will look exactly the same because I just took the exact DOM elements again and again. Now, however, these are familiar tools because I'll also share the code. So here you have Astro. Now you will see I am still using React Hot Toast. I'm still using React Strap. All the traditional tools that you guys saw. And all the components also. You look at the header, it's built with React. Same, the design system stuff, which makes like sharing components extremely easier. Footer also like built with React. Also the location and calculator, these are exact components that I had previously in my Next.js page. Now let's look at how much JavaScript is like loaded for this application. Let me look at the network tab, JavaScript, do a full refresh. And surprisingly, there is like zero JavaScript load for my home page. But I got the benefits of all the JavaScript tooling. Let me go to the about page. Again, like zero JavaScript. Now let me go to the calculator page. This is where I need the interactivity for the first time. You will see like JavaScript loading. And previously what was like 100 KB became like 70 KB because I cut off Next.js's JavaScript. But it's still the same amount of JavaScript that it loaded. So what ended up happening is only when my React component came up that needed that rendering, okay, it shows that count and you have that fully working calculator app ready for you to like use. Now go, yeah, so it's hydration, but the way this hydrates is you can opt in which component needs that hydration. So the way hydration works is you render the HTML, you give the control to React, that handshake from HTML into JavaScript, that you can control in newer island frameworks. So let me go to the location, and it will ask for my location, and it will like print the location, and the famous feedback pop-up also came. So this time when I click submit feedback, surprisingly that feedback alone died and disappeared. But rest of my application is like still fine. Again, I can go to the same location page. The feedback will just show up like usual. I can click, it won't affect my rest of the application because now, if you look at the elements HTML, the way they are like rendering, you will see the header rendered as a plain HTML tag, just like usual. But the body basically rendered through a special tag called astro-island. So what they did is they wrapped around the component that opted in for hydration and wrapped it around with astro islands and loaded the script that is needed only for that component along the same DOM. So even if your component like crashes, some runtime error happens inside that component, which is like partially hydrated, the damage has been like contained within that small area where the JavaScript is loading. So I get the performance that is like crazy performance of HTML. So if I have like 100 pages, even if I have 100 contexts, as long as I'm not opting in my home page for client-side iteration, I get the full performance that is needed. Second, I get the component-driven system where I still manage to use React components. All the React Chakra UI, like all the material UI, all the things that tell us how difficult a dropdown is, we can use all of those libraries. And at the end, you also get that nice performance, which is used to be a pretty big problem for the older SPA frameworks. Now, with these new frameworks, most of the bottleneck are getting addressed. So next time when you guys like see that your application is slow, before you guys like jump into any optimization, if you take a step back, it's because we are executing too much JavaScript in places where we actually don't want. Okay, let me also walk you guys through the Astro code. I can't teach you the whole framework, but you can get an idea. So Astro has the same pages structure like Next.js. This time you will see the files are using a new extension called .astro. Now in my index.astro, you will see I'm just using React component like usual. In the about page also usual, and in the layouts also there is like some common shared pages. You can put inside layout directory and you can use your React component as usual. So there is not much difference. React components are built in TSX, imported into .astro file, and just being used like normal. Now, when I need the interactivity for the calculator components, okay, where the UI needs to run, I need to give a special argument there, attribute there, called client load, which basically tells Astro this component you can render it on the server side, but client also it has to work. So Astro puts that entire islands DOM element around this component. So this is like extremely easy to learn. And also Astro like champions the new thing, which is edge rendering, by making all the server side logic run on the edge. So that is something I'm planning to take as a separate topic for some other time. But basically the new generation of frameworks, they are like introducing a lot of really exciting stuff. So that's pretty much it. We started off with how you generally build a React application. What will be the problem? So the problem is we tend to load lots of JavaScript, especially for places where we actually don't need the JavaScript. So the solution, we go for a framework that supports islands architecture, or we can also implement our own islands architecture. It's not very hard. In case like you don't want to like rely on one more framework, you want to do something in-house. It's similar to what I showed in the second part, basically where I showed how I built things with HTML, right? A little bit of server-side language like Ruby or Express, you can bring islands into any application on your own without having to adapt to an entirely new framework. That is also doable. So, any questions, guys?
What about the context and how we can share data across the different components? And say
Mm.
some of the components are server side and some of the components use client. But I want to make sure that whenever I take something and that particular component should I use client use client there also?
Okay, that's a very good question. So the one place where this entire islands like has problem is that sharing state across different islands, because they all become like independent detached context. So basically Astro themselves have got like their own state management system where you put object in from one island, it will be shared across another island. So there is also newer tools like Preact came up with something called signals. So that is used by Fresh, the other framework I told you on Dino, used to share data across these islands using that framework called Preact signals. And the signals work in this one also, Astro also. I have tested it. And one of the traditional state management tool you might have used called Zustand React, which doesn't need a context. That also works across the islands when you have to share. So there has been like new set of tools coming up which don't share the context but share the state through JavaScript itself. So they can share the data across these islands. So that's a good question. I almost like forgot to include it in my talk. Yep.
One question: when you're saying the Next.js load a lot of files, which is subjected to the Next.js file. So why can't we, that are files which are common to the application, why can't we cache it first time and use it and we move on?
Good thing. But for the first load, it will be slower, right?
But we can preload before.
So the way people generally interact with app is you have to impress them on the first load. If you cache it on the first load, right? Second load, your page will be performant. But in that first load, you lose that performance gain, because take any e-commerce websites or take any SEO or marketing pages, it's the first load that you have to like impress people.
Can you do that server side rendering for the first page? And then
That is what Astro is doing here. So that is exactly what Astro is doing. It renders the pages fully on server. Whenever you want specific pages that needs to be like rendered on the client, you opt in using client load for that pages alone. So Next.js 13 is doing it now, but it's still in beta. So this Next.js app also I built with Next.js 13 only, but the actual Astro part, React Server components, was still in beta. So I just went with the usual approach to show you guys how it loads too many JavaScript files. Yep. Any other questions, guys? Yeah,
So
I'll come next. Yeah.
what's the use case of this kind of architecture? Because if you consider SaaS products, every component that is on the screen.
Yeah, yeah. So let me like show you a product that has like such an interactivity. So you go to sheets.new. This is an example. This is a actual use case of an SPA because every single button here is interactive. Okay, so this is not where you are supposed to use the islands architecture. Here you actually need to build an SPA. So the use cases vary. Now say that you are building an app that needs like, for example, a landing page, or you have like lots of blog pages, extremely SEO intensive, extremely the especially when you are like inviting a user to your product. The first set of pages the users see, usually we call it onboarding pages, like the welcome, sign in, all of those screens. There you have to like impress them on the first load, because if your app takes any performance hit over there, users will drop off. So those are the pages where you actually need to like go for this optimization technique. You have to do islands and make sure that it's only rendering the HTML and it's rendering it fast. You can render JavaScript, but make sure it's very vital. Give it a vital score. How often you have to like load that JavaScript? Is it worth it? That are the decisions you have to take on those pages. Okay, I'll go with him first. Yeah.
I think it was slightly similar. Right? My question was, how does actually JS perform on screen? Not with lines and performance. Like when you're saying it's unsigned, it means there must be some processing that goes to the server. Now, if you're talking about few hundreds of users, fine. But if you're talking about a lot of users, like 1,000 and
Oh,
kind of workload.
so this is where the edge rendering concept that I last mentioned comes into play. So what happens is, instead of rendering this, now Astro requires a server for it to run. If your page has any dynamic SSR logic. Okay, so what people are adopting now is they use Astro with an environment that is like charging per invocation rather than the compute. So AWS serverless, AWS App Sync, Cloudflare Workers, Vercel, Netlify. So these are all platforms which are like now moving towards SSR friendly support. So what happens is you have like 1,000 users, they will invoke 1,000 different serverless lambdas. Okay, to make sure everyone is having the same consistent performance. And since it's a serverless environment, you get very few bills. Like right now, AWS Lambda, right, charges some $5-10 per million invocations. So the environment, server side environment, is also moving more SSR friendly right now. So
Overall perspective of I can't just do anything, right? If it's rented for the server side. A very hypothetical example. I have to fetch some data from the database and then render it and package it into some form, some table, and then
got it.
render it in the
So
cloud.
here, here is the fun part. What Astro actually solved this problem. So what they did is, by default, all SSR rendered page in Astro are streaming SSR, which means as and when an HTML is ready, it starts streaming it through. So if any of your small block like needs a lot of data, okay, you can just go to the Astro streaming SSR section. What it will do is, it will load that separately, but while it is loading, rest of your page will actually render for the user immediately. The comp
That whole component, let's say that table, that you would be the layout and everything.
layout and everything will start loading faster.
That would be one of the client side, right? Like that particular component came in, and that has to fit into the page. So that again requires JS execution involved.
It needs JS. What you have to do is, you have to be little smart in that area. Instead of like loading 1,000 data, you just stream the first 10 here.
So that's a UX problem. Like that's why I said that there changes depending on what extent
Astro can pretty much handle this scenario. It's just that they have a different approach. The thing is, first SSR you load like 10 data, let JavaScript take over the remaining 1,000. That way you can like get that same performance that you get from an SPA.
and how much concurrency and all the issues does that come into play?
It doesn't. So ideally, like when you're doing SSR, okay, go for a serverless environment. because that is scales. Just because 100 user come in, your server won't be like busy. Serverless can invoke 100 different parallel concurrent connections and start serving the users. And usually when most Astro pages, when you're doing SSG, you're not fetching data on the fly, it just serves the HTML directly. So it takes care of SSR, SSG naturally within itself. If it knows the page doesn't need any actual JavaScript context, it just serves that HTML directly. You won't be charged for that compute. Yeah, yeah. Netlify and Vessel, they all figure this out easily because they are all built for that serverless. Right now, AppSync is like extremely good for, especially if you want to host these pages on enterprise. So the options are there. Even DigitalOcean has got functions now. They got their app platform also that does all of that. So cloud providers are like available. Yeah. Okay. The thing is, there is nothing to selectively hydrate in that sheets.new page. Let me tell you what will happen if I went with the islands on that sheets page. What happens is it has to like selectively hydrate and share data across different islands, which is actually more complex than sharing the state across a single JavaScript thread. So if you have like 100 islands in that page and I have the state shared across the 100 islands, the application will actually start suffering performance issues. So it comes down to the part where you have to like select the right tool for the job. Anyone else? Yep.
So is there any performance bottleneck when we have 100 islands of same paper? For example, I have 100 islands of React, and then I believe Astro is analyzing.
Yeah, it basically it's similar to how Webpack's structure works. If it loads React's JavaScript once, all the other islands will just share the same React JavaScript from cache. So that performance has been like taken care of also. And it gets even more interesting because these islands are like independent of each other, right? You can use React and Angular in the same page, different islands. Wouldn't recommend it, which means it has to load 2 runtimes now instead of one. But it is possible, which means you can have like one team building one page in React, another team building the same page in React or Svelte. It is possible through this architecture. So it is generated for every request, but Astro has its own server-side caching also, which contains, if the data is not changed, it will just stream out that HTML directly. So it has the deduction inside, but I'm how to like get to read about how it is like filtering that out. But when I checked, the compute resource was like extremely less. If I have like only 2 pages that runs Node.js code, only those 2 pages are actually coming under compute. Other comes under like direct static files. Yeah. Cool. Uh, just one last word. So we are hiring at Go slash, like Yogesh said. So if any of you are interested, you can like reach out to us on that email hiring@oslash.com. Also like oslash.com/careers. All the applications that I showcased, I'll like share it with the community organizers.